Okay, let us proceed now for the solution of differential equation. A solution of differential equation in the unknown function y and its independent variable x on the interval I is a function y of x that satisfies the different equation identically for all x in the interval. Okay, example, we have shown that y equal to c e to the x is a solution of y prime minus y equal to 0. Okay, we have to prove that your y equal to c e to the x is a solution of y prime minus y equal to 0. Therefore, we have y equal to c e to the x, get the y prime equal to c e to the x. From that equation, we can say that your c is equal to y prime over e to the x. Then, let us substitute the value of your c to the given equation. We have y equal to y prime over e to the x times e to the x. But e to the x over e to the x is 1. Therefore, we have y is equal to y prime, or y prime is minus y is equal to 0. Therefore, y equal to c e to the x is a solution of y prime minus y equal to 0. Next, we have show that y equal to negative cosine x plus c is a solution of y prime minus sine x. Remember that your c is an arbitrary constant. Therefore, we have y equal to negative cosine x plus c. We have to prove this one is a solution of y prime equal to sine x. Get the first derivative, y prime, negative. The derivative of cosine x is negative sine x. Okay, y prime equal to negative times negative, positive sine x. Therefore, y prime is equal to sine x. Y equal to negative cosine x is a plus c is a solution of y prime equal to sine x. Okay, next problem. Verify that the function y equal to c1 e to the x plus c2 e to the 2x is a solution of the differential equation y double prime minus 3y prime plus 2y. Therefore, we have y equal to c1 e to the x plus c2 e to the 2x. Y prime is equal to c1 e to the x plus 2 c2 e to the 2x. Y double prime equal to c1 e to the x plus 4 c2 e to the 2x. Then substitute natin, you have y double prime minus 3y prime plus 2y equal to 0. Y double prime, that is c1 e to the x plus 4 c2 e to the 2x minus 3 y prime is c1 e to the x plus 2 c2 e to the 2x plus 2 times, which is y, c1 e to the x plus c2 e to the 2x equal to 0. Okay, c1 e to the x plus 4 c2 e to the 2x distribute minus 3c1 e to the x plus negative. This one is negative kasi positive times negative. Therefore, we have minus 6c2 e to the 2x plus 2c1 e to the x plus 4c2 e to the 2x equal to 0. c1 e to the x, negative 3, c1e di negative 2 plus 2, 0. 4, c2, negative 6, negative 2, plus, this one is not 4, instead, this one is 2. This one is only 2. Okay, this one is 2. Okay, therefore, that is positive, negative 2, tsaka positive 2, 0. Therefore, 0 is equal to 0. Therefore, y equal to c1 e to the x plus c2 e to the 2x is a solution of y double prime minus 3y prime plus 2y equal to 0. Okay, next. Determine whether y equal to x squared minus 1 is a solution of y prime to the fourth plus y squared equal to negative 1. Okay, note. Okay, you have to note. Okay, if you can notice, if we get your y prime here, you have y prime equal to 2x, 2x. Okay, if we're going to substitute it here, you have, ang given natin is y equal to x squared minus 1. Okay, therefore we have 2x raised to the fourth power equal to plus 2x. Therefore, that is your y prime to the fourth plus y, that is yung y squared natin, plus x squared minus 1 raised to the second power equal to negative 1. Therefore, we have 16x to the fourth plus x to the fourth minus 2x squared plus 1 equal to negative 1. As you can see, okay, this one, your y equal to x squared minus 1 is not a solution of y prime to the fourth plus y squared equal to negative 1. Dapat etong left side ay equal sa negative 1. Therefore, your y equal to x squared minus 1 is not a solution of y prime to the fourth plus y squared equal to negative 1. And note that the left side of the differential equation, must be a non-negative for every real numbers, a real function y of x and any x, since it is the sum of terms raised to the second and fourth powers. While the right side of the equation, negative 1, since no function y of x that will satisfy this equation, the given differential equation has no solution. Okay. Next. Okay, determine C1 and C2 so that y of x is equal to C1 sine 2x plus C2 cosine 2x plus 1 will satisfy the condition y pi of over 8 is equal to 0 and y prime pi of over 8 is equal to square root of 2. Y of x is equal to C1 sine 2x plus C2 cosine 2x plus 1. Okay, therefore we have y, substitute this one, pi over 8. Your x, which is pi over 8, sine 2 pi over 8 plus C2 cosine 2 pi over 8 plus 1. Okay. But y pi over 8 is equal to 0. Therefore, we have 0 equal to C1 sine pi over 8 is pi over 4. Why? 2 over 8 is 4. Plus C2 cosine pi over 4 plus 1. Okay, if you notice your pi over 4 is equivalent to 45 degrees. Pi over 4 is equal to 45 degrees. Using the special triangle of 45 degrees, you have 1 square root of 2. Okay, we have 0 is equal to C1. Sine 45 degrees, okay, when you say sine, that is opposite over the hypotenuse. 1 over square root of 2. Let's conjugate square root of 2 over square root of 2. Okay. Plus C2 cosine, ang cosine natin is opposite, adjacent over the hypotenuse. Therefore, that is 1. Wait. This one is 1 over square root of 2 times square root of 2 over square root of 2 plus 1. Okay. Common factor, therefore, this one is square root of 2 over 2. Common factor natin is square root of 2 over 2, C1 plus C2 plus 1. Okay. From that equation, we can say negative 1 is equal to square root of 2 over 2 times C1 plus C2. Okay. Therefore, your C1 plus C2 is equal to negative 2 over square root of 2. Again, conjugate ng square root of 2, C1 plus C2 is equal to negative 2 square root of 2 over 2, or that is negative square root of 2. Okay, we have now the value of your C1 and C2. Since y prime, let us get your y prime. Y prime of x is equal to C1 sine x. What is the derivative of your sine? That is cosine. Therefore, we have 2 C1 cosine 2x minus 2 C2 sine 2x. And the derivative of your 1 is 0. Okay, therefore, we have y prime of pi over 8. Y prime pi over 8 is equal to 2 C1 cosine 2 pi over 8 minus 2 C2 sine 2 pi over 8. Okay, therefore, this one y prime pi over 8 is equal to square root of 2. Substitute natin. You have square root of 2. 2C1 cosine pi over 8 times 2 is pi over 4. And pi over 4, again, is 45 degrees. Therefore, for cosine, we have 1 over square root of 2. Or, that is square root of 2 over 2. Minus 2 C2. Again, sine 2 pi over 4. That 2 pi over 8 is pi over 4. The 45 degrees again. Okay, for sine, we have also square root of 2 over 2. Okay, if we get that value, we can say that your square root of 2. Then, what would be the value of your square root of 2? Square root of 2 is equal to square root of 2C1. Cancel ang 2 natin. Minus C2 square root of 2. Okay, therefore, we have the value of this one. Okay, and then, the common factor now is C1 minus C2. Common factors, square root of 2, C1 minus C2. Therefore, the value of your C1 and C2, C1 minus C2 is equal to 1. Kasi square root of 2 divided by square root of 2 is 1. Okay, this one is equation number 1. Equation number 2. Solving simultaneously your 1 and 2, we obtain that your C1 would be equal to negative 1 half square root of 2 minus 1. And your C2 is equal to negative 1 half square root of 2 plus 1. Okay, this one is the final answer. Okay.